Students, we will be continuing chapter 2, force and pressure. The next topic that we'll be studying is mass. The mass of a body is the quantity of matter or material contained in it. How much matter a body contains, that is known as the mass of the body. The mass of a body is a scalar quantity and it is denoted by letter m. Small m denotes mass. Scalar quantity means it does not have any direction, it only has magnitude. The SI unit of mass is kilogram, that is kg. The mass of a body is measured by an equal arm balance, also known as beam balance. The beam balance is shown in this figure. It is used to measure mass of a body. The mass of a body is same everywhere, that is the mass of the body is constant and never changes. It does not change when we move from one place to another. Mass of the body remains same. And mass of a body cannot be zero. Mass of a body can never be zero. You can never say that a mass of a body is 0 kg. Mass never is zero. It always has some value. Next topic is weight. The weight of a body is the force with which it is attracted towards the center of the earth. Weight is denoted by W. Capital letter W denotes weight. Every body is attracted towards earth due to the force of gravity which is applied on the body. Now, due to that force of gravity, the force which is experienced by a body because of that attraction is known as weight. And that force of gravity also produces acceleration in the body. The acceleration which is produced by the force of attraction of the earth, the acceleration which is produced by that gravity is known as acceleration due to gravity, and it is written as g. That is, it is denoted by symbol g. Small letter g denotes acceleration due to gravity. Weight of a body is always equal to m into g. This is a formula for calculating the weight of the body. M denotes mass of the body and g denotes acceleration due to gravity. Weight is a vector quantity, that is, it has a direction also, because weight of the body always acts in downward direction. Weight of the body always acts in downward direction, and because it is having a magnitude as well as direction, therefore it is a vector quantity. The SI unit of weight is same as SI unit of force, because what is weight? Weight is the force with which it is attracted. It is due to gravity, the force which we are experiencing is weight. So weight is having same SI unit as force, and the SI unit is Newton. It is denoted by capital N. Weight of a body, from the formula we see that the weight of the body depends on the mass of the body, m, and acceleration due to gravity. Weight depends on mass and acceleration due to gravity. Now we have just learned that the mass of a body cannot be zero and it is same everywhere. Since mass remains same everywhere and for a particular place, the value of g is also remains constant. So since mass is constant at a place, we can use mass as weight of the body. That is, at a particular given place, we consider weight as the mass because it is constant for a place. Weight and mass are considered same thing. Now, because weight depends on g also, that is acceleration due to gravity. And the value of g, that is acceleration due to gravity, changes from place to place. Value of g changes from place to place because weight is equal to m into g and the value of g is changing. So when value of g changes, the weight also changes from place to place. If the weight of the body is having particular value on earth, the weight will be different on moon due to change in gravity. Weight is not constant. As we have just seen, weight changes. When it is changing, it is not constant. And weight can be zero. It can be zero also, where the value of acceleration due to gravity is zero. If g is equal to 0, then weight can also be 0 because weight is equal to m into g. And if g is equal to 0, then weight will be equal to m into 0, that is equal to 0. So weight can be 0 also. The weight of an object is measured with the help of a spring balance. Mass we were measuring with beam balance, weight is measured with the help of spring balance. The certain points of difference which can be seen between mass and weight are: mass is amount of matter contained in the body, but what is weight? Weight is the force with which it is attracted by earth. Mass is measured with the help of a beam balance, but weight is measured with the help of spring balance. SI unit of mass is kg and SI unit of weight is Newton. Weight can be 0, but mass can never be 0. Weight can change. Weight is not constant, but mass is always constant. These are some points of differences between mass and weight. Now we have just read weight of an object is measured with the help of spring balance. We will now learn about spring balance. What is a spring balance? Basic definition of spring balance will be: it is a device or apparatus which is used for measuring the weight of a body. With the help of spring balance, we measure the weight of a spring body. The spring balance is shown in this figure. We will study the structure of a spring balance first. What does it contain? A pointer and a long rod ending in a hook is fixed to its lower end. We have a pointer. This red color denotes the pointer. It tells us about what is the weight of the body. It is a pointer and it is a long spring, it is a long rod, and at the end is a hook. This is a hook. This curved is a hook. The spring is enclosed in a metallic case. This represents the metallic case. All this is metallic case, so that the pointer moves over the scale fixed to it. And as the calibration, as a numbering is there, this is the scale which is fixed on the metallic case, and this red colored pointer moves on this scale and tells us about the value of the weight. The metal ring on the top is there. This is a metal ring on the top, which you can see. This is a metal ring and it is just used to hang the spring balance on somewhere. And the load is hung on the hook. That is, whatever object we are having whose weight we have to measure is hung with the help of this hook. In this hook, that load is put. Now, a spring balance works on a principle. What is the principle? That is known as principle of spring balance. What is principle of spring balance? A spring balance works on the principle that when the body means the load, the object whose weight we have to measure, is hung on the spring, when we hang it here, the spring's extension means to increase in length. Spring extends itself. When load is put on it, it increases its length, it gets stretched. Increase in length is proportional to weight load. What do you mean by proportional? Proportional means if the weight keeps on increasing, then the extension in the length of the string also keeps on increasing. More weight you put on the hook, more is the extension of the spring. More weight, more spring. If you make the weight two times, if you increase the weight 2 times, then the extension and the length of the string will also increase 2 times. This is principle of spring balance, that the extension increase in length is proportional to weight, that is load, which we have to measure. Now, how do you measure the weight with the help of spring balance? You hang the spring balance with the help of this ring at the top. Then you put your load on this hook here, which is at the bottom, and then as you put the hook here, the spring gets extended and this red pointer comes down according to the weight. Weight is calibrated in kg here. 0 kg, 1 kg, 2 kgs and so on, and in between we have one division shows, the small division shows 100 grams. One division represents 100 grams. When you hung the weight, the spring gets extended and this pointer moves down. If this red colored pointer will stop at 4, means the weight of the object which we have hung on the hook is 4 kg. This is how a spring balance works. This was all about theoretical portion of the chapter. Next time we will discuss the numericals. Till then, study what has been explained. Thank you.